This video will begin our discussion of what a conservative vector field is and how to find a conservative vector field given what's called a potential function. Okay, a vector field is called conservative, right, and nothing to do with political stuff. When there exists a differentiable function, so some function f, we're going to call it a lot here, the curriculum we use, my notes, we're going to use phi as that function. Here they use f, it doesn't matter, it could be anything. But a vector field is called conservative and it has some properties that we're going to be interested in that I'm going to show over the next 2 or 3 sections. But as of right now, here's the definition. If I can take the gradient of some function and get my vector field, it is conservative. The function that we can take the gradient of is called a potential function. So they want us to find, in this example, it's very straightforward, thankfully, find the conservative vector field for the potential function by finding its gradient. So right now we have a function, not a vector field, but I would like to find a conservative vector field. Well, doing that, all I have to do is find the gradient of g. Remember, the gradient of g is just g with respect, partial with respect to x, and g partial with respect to y. So I just got to find each one. I'm going to go ahead and throw it in here because it's not too difficult here. We get 10x plus 3y. That's with respect to x. And then with respect to y, we got 2y plus 3x. That's all they wanted. That vector field, this is a vector field, right? It's a vector. I could plot it all over the plane and get a field. This is a conservative vector field only because it came from this potential function. If I take any function and I take its gradient, that gradient field, if I'm going to call it a vector field, which it is, if I take the gradient, that vector field it produces is conservative. This is going to be great because conservative has a lot of properties that are very helpful for us. But this is the plain Jane definition where it comes from. The properties are not the definition. The definition is that I took some function and I took its gradient to get this vector field. Hence, the vector field is called conservative.